Hello and welcome back to this SlimDevOps episode 13. This was originally recorded live on twitch.tv/SlimDevOps on the 9th of September. If you're watching this after the fact on our YouTube channel, then please do consider heading over to our Twitch channel and giving us a follow so you can join in person. Once again, I'm joined by Pieter. Hello there, how are you?
Hey Martin, I am doing great. How are you doing?
Yes, very well, thanks. Bearing up. What's new with you?
Not so much. We got a lot going on. It's like things have kind of kicked into high gear here now that we're past the Labor Day weekend and all of that, and it feels like everybody's getting ready for conferences and KubeCon, and people are back at work, back from their holidays, all that kind of stuff. So yeah, we're cranking right along here. Got one thing coming up that's pretty fun. Next week, I think we're going to have an interview with John, our CEO, and a pretty cool little newsletter. I'm not sure if people on the stream have heard of it. It's called console.dev. It's sort of a new developer tools listserv. I'm curious if people in the chat have signed up for it or anything before, but it's a guy, David Mighton, who's out of the UK, who put this together, and then there's this really amazing woman, Jean Yang, who does the podcast with him, and they talk about developer tools and stuff like that. So yeah, we did an interview with them that's going to come out next week. So just encourage people to sign up for their newsletter, check out their content, and then pay attention to that Q&A with John. It was pretty fun. He talks a lot about his home setup and his traveling setup, and a lot of geeky stuff about equipment, which I'm sure, Martin, you would be into, and
definitely
I would be into.
Sounds like my sort of thing. Definitely, yeah.
Yeah. So that's what I got going on. You've been in the news on the Twitters over the past couple hours. Big news out of the Ubuntu podcast, huh? Yeah.
Yes. We after 14 years, we've decided to bring the Ubuntu podcast to a close. So it's a day of mixed feelings. I think that there's some sadness there from the three of us, and also sort of a sense of relief and optimism for what will come in the future. But yeah, a lot of people are upset, and it's one of those things where you find out just how much something you've made means to people. And so, yeah, there's been a bit of an outpouring. So thank you very much for everyone who's, sent us your kind words and your memories of the podcast over the years. It's been quite touching. But yeah, so that's the end of an era for us. We've got 3 more episodes and then that'll be it.
Yeah, well, I think you can probably determine how good and how loved your podcast is by the number of Kermit staring out the window at a rainy day Giphies that you get on Twitter when you announce that. You guys have gotten quite a few of them over the past couple hours. It's a great podcast, so I'm sad to see it go. I only recently started listening, but yeah, it's really good. So
yeah.
But you guys will come up with something cool afterwards, I'm sure. So.
Well, maybe we'll just have to see. I think we need a bit of a break, and maybe a long weekend on a beach in the sunshine.
Yeah. I think we could all use that at this point.
Right. So on this stream, though, we've got some plans for what's coming up next, right? So what are we going to be doing?
Yeah. So welcome to everybody in the chat. Looks like it's going off. Thanks for joining. If people were here 2 weeks ago, they saw sort of the first Containers 101 and hopefully experienced that with us. I know a couple people even built their own containers, which was awesome. It was great to see French guys forking of the Git repo, and I know a couple other people had an experience there. What we realized on that stream was actually that there's a couple areas of containers that people could really want to learn, and one of them is around volumes. That was something that came up. So volumes are ways to interact with files that are local on your local host, but the container can interact with them, because as we know, containers are ephemeral. So when you shut them down, you lose all the data in them. But if you want to run a database or store some images or something like that, that's what we'll be walking through. And we thought it would be fun to kind of spin up like a home server kind of photo app, because that sort of uses database and it could use some image stuff. And so we'll try that for next week. So I'm kind of actively working on that one. So that one should be pretty fun. So.
Great. Yes, I'm looking forward to that one. It's a good topic, and it kind of makes containers come to life, because at the moment these have all been very much sort of sort of staged examples to demonstrate the how to make a container rather than actually making like a real life container. And this is like the first big piece in moving away from examples into real, good stuff. Yeah. So I think it's time to get into this, right? We're going to do another one of the workshops. It is a continuation of the one we did 2 weeks ago. So for those of you that were here 2 weeks ago, we're using the same 2 Git repositories. We'll bring those up on screen in just a moment. And if you weren't here 2 weeks ago, don't worry. You can actually jump straight into this one without having had to have done the previous one. But if any of the language we use or concepts we introduce that you're not familiar with them, then you can go back and watch the previous episode afterwards and sort of catch yourself up. But you shouldn't find that this is like too overwhelming. This is kind of stepping up from beginner into sort of intermediate. So with that,
I guess one other note on that too. One thing we're going to try, I know a lot of people have joined the Discord over at Slim.AI, and one thing we always realize when we do these is there's always a lot of questions afterwards. People kind of want to interact, but it's pretty late our times when we stream these. Not sure where everybody else is, but so tomorrow morning we're going to do an office hours in the Slim Discord. It'll be from 10 to 11 a.m. Eastern, and we'll jump into the live channel. Try this out tomorrow so you guys can kind of help us guinea pig this, but we're going to jump in there and we're going to kind of follow up from today's workshop in that Discord, and we'll be around to kind of answer questions and do some live coding. And so people who have projects can come hang out with us there and do some work, or if you want to kind of see the next step after this, should be pretty cool. So
yeah, so I've just posted a link to our Discord channel in the live chat on Twitch. If you think you're in our Discord, make sure, because this is the Slim.AI community Discord I've sent a link to. So do click it. If you're already a member, nothing is going to happen. And if you're not in there, it will bring you in. And like Pieter says, we'll be doing a live sort of continuation of this workshop tomorrow to show you sort of some next level stuff you can do with the Slim developer platform. And we'll be handing out invite links to anyone that needs them in order to get signed up and use that stuff. So it'll be a continuation of this, leveling up on the Slim platform. But today it's just Docker 101 more. Oops, let's try that again. This one. There we go.
I messed this up. That was my fault. We had it all planned.
No, it's fine. It's fine. Right then, so the first thing is, this is where today's workshop lives. It's on the SlimDevOps org on GitHub, and it's the Slim Containers repository. And you'll find a folder in there. It's Containers 101 Prod Ready Workshop, and here is all of the content. So all of the text is here. So if you want to, pause the video and, read this and digest it after the fact, everything you need is in here. So what is this? It builds on the previous 101, which was like absolute beginners Docker container creation. And it's kind of a practical example of an article we published on dev.to some weeks ago. So it's creating production ready containers. So this is taking your very simple first container image and applying some best practice so that you can put it into production and know you're doing some of the right things in order for that container to, operate well in a production environment. So what are we going to look at? We're going to look at running things as not root inside the container. We're going to look at pinning base images and why you would want to do that. We're going to look at better layer caching and also cleaning up cached files in the image creation process. We're going to talk about the difference between ENTRYPOINT and CMD, and it doesn't matter if you don't know what either of those things mean right now, because we'll explain as we go. And then finally, we'll introduce using a WORKDIR. So that's what we're going to cover off today. And out of scope is just like last time, we're not going to get into slimming containers today. You want to join our Discord for the office hours tomorrow, where we'll be getting into that and some other stuff. We're not doing multi-containers, and we're not doing logical volumes. We said we're going to be doing that next week. and we're not going to be doing any shipping containers via CI/CD or K8s or multi-stage builds. We will be covering multi-stage builds in the future, and if you don't know what that is, then do get followed to this channel, because you won't want to miss that. So if you're on Mac OS or Windows, you can install Docker Desktop, and you'll have the Docker tools that you require. If you're on Linux, then here are the steps to get Docker installed on Ubuntu or Debian. Those instructions are good for. Sorry if you're on another distro, pull requests welcome to add, flesh out our installation instructions. So this is the repository that we're working from. So if you clone that, you'll have all of the resources locally. You don't need to pull this Git repository. You can just browse it on the web at the URL that you can see at the top of the screen. However, this is my very simple, in air quotes, web app that we're using as the application that we're putting into a container, and what we used a couple of weeks ago. So if you don't have this, you can clone that repository, and then we want to check out this branch, and this was the last branch we were using at the end of the workshop a couple of weeks ago, where we were basically sort of showing you a more real world way that you could, create your container images. So this is actually the Dockerfile that we had at the end of that process. So we were using Ubuntu latest. We were running some commands to upgrade, apply the updates to Ubuntu. We installed Nano and Git inside the container to give us some developer tools, and we added the Python 3 minimal package to provide Python, which is what was required for the app to run. We then inject the app, which is a single Python file, into the container, and then we create an entry point, which is when the container is executed, this is the thing that runs when the container starts. So that's where we're starting. So if I just switch to a terminal and I cat the Dockerfile, I should have a Dockerfile here, which is exactly what I've just shown on screen.
And just a reminder to some of the people who might be new. I mean, obviously, like installing Nano or installing Git, we kind of know that's not something that you would do. We used it in the example last time to sort of show the hard way of doing it, or sort of the wrong way of doing it, as a way to get to the right way of doing it. And then I think this tutorial, right, Martin, is going to bring us even further down that path, where it's like, okay, now we have a very basic Dockerfile, but a lot of tutorials just leap off there. It's like, actually, you'd want to do some things to this Dockerfile to make it actually like a lot better, and that's what we're doing. Indeed.
And I also see in chat that Yannick is asking if we're going to get cookies at the end of this. I tell you what, those of you that join our Discord, I'm Wimpy in the Slim.AI community Discord. If you message me with emotes or emoji of cookies, and then DM me a shipping address if you feel comfortable doing that, I will make sure that you get some Slim.AI stickers or socks or something. So not cookies, but if you send me emotes of cookies and you PM me your shipping details, we'll get something sent to you. How's that? Is that a fair deal?
Yeah, we don't have Slim.AI cookies. We could make some Cody cookies, but I don't know if they'll keep. We've got kind of an international crew here, so it might be a lot. But I think Jillian's in chat. Maybe she can.
Yeah, I saw Jillian earlier. I hope I've not just burdened her with an impossible task. But there we go. It's a fair offer, I think.
She said stickers and socks. So stickers and socks.
So confirmed. Yeah. There we go. Jillian has currently got all of the swag in boxes in her house, I believe, at the moment. So there we go. Swag confirmed. So we're going to do non-root user first. So in our example, we don't set a user explicitly in the Dockerfile, so therefore everything runs as root. And that's not really an issue when you're doing local development, but if you want to put that into production, it will definitely cause raised eyebrows from your sort of DevSecOps team. And if you don't know why they're raising eyebrows at you, they'll explain in glorious Technicolor, why you don't want to be doing that. So we're going to
most base images are going to start as root, right? So when you're grabbing Ubuntu or Python or Debian or whatever, it's probably going to start as root, right?
Yeah, indeed. And most distro container images, and also like the language and framework base images for things like Node and Python and what have you, they usually have like a predefined user for running applications. So in the example of Node.js, there is a user, it's just Node. And in the Ubuntu container image, which is what we're using today, we have a couple of options. There's an account called Nobody, and there's another one called www-data. So today we're going to use www-data because our app is almost a web app, and it's probably more fitting for people doing things with Python and PHP where they've got a web app. That would be the account that you want to use. So we're going to add a couple of lines to our Dockerfile. So these are the lines we're going to add. We're going to add a run command to change the ownership of our Python file, and then we're going to add the user instruction to basically tell the Docker container to use this user account context when it launches the app. And this is what the Dockerfile is going to look like when you've made both those changes. You'll see that here are the two lines we're adding. So I'm just going to take all of that. In fact, actually, let's do it the quick way. We'll just take that. I'll go over to my terminal, use the glorious Nano as we agreed 2 weeks ago. The best editor.
Except for Vim.
Oh no, not again.
Not that again.
There we go.
Eric in chat says that he uses his workstations user when he's doing dev containers in R or Python. So he's also bridging the gap of R and Python for us. So in Vim we can bridge that gap. But so I think that's a good idea. I mean that works. I do that sometimes too for dev images. I wonder if for production images, if it's better to use sort of a specific user that's already sort of pre-baked into the image, or is it okay to kind of like just define whatever user you want?
You can definitely create your own, non-privileged user accounts. That's absolutely fine. But I've in the past I've just used the Nobody account when you're setting up a service that is running as a non-privileged user, because it's there in every install. So it's a step you don't have to worry yourself with.
Sure.
Right then. So I'm going to build the container. So it's going to build, and we're calling it redirect live chat. And we're adding the tag non-root because this is the change that we've made. So, that ran quite quickly, and that's because obviously I have these things cached from when we did this a couple of weeks ago. So the only change that's really been made here is this changing the permissions and what have you. And if we run Docker images now, we can see here's our new container image. It's the same size. It's 22 seconds old, and there's our tag. So there's that. And then if we come back here, we can see that this is the command to run it. Now, when we did the workshop a couple of weeks ago, there was a bit of consternation about running containers and leaving the container images behind each time you invoked the app. So we're adding the tac-tac-rm parameter to our Docker run, and what this will do is run the container, and when that container shuts down, it will automatically remove the container image. The container image and the Docker image are different. The Docker image is the thing that is used to create a new container image that is executed and run, and then that is ephemeral and gets thrown away at the end, but you still have the live chat non-root container image each time. So we'll run our app, and we'll go
see a bunch of people talk. So our Nano Vim comment kicked off a little bit of additional, sort of, I'd say, longer tail editor comments. But a lot of people are talking about VS Code, and I just want to make a note about VS Code that I love VS Code. I use it a lot. And their Docker plugin is actually quite good. And as Martin's showing, like Docker image and container management can get pretty complicated, or it takes up a lot of hard drive space and stuff like that, a lot of memory. Using flags like this --rm that he's showing now help remove containers when you're done using them. The VS Code plugin for Docker also contains a lot of management, sort of like desktop management type of tools that make it easy to kind of take containers out after you're done with them and stuff like that. So for the VS Code users, highly recommend getting the Docker plugin. It also helps you sort of lint your Dockerfile as well.
Yeah, and it's also got like syntax help tooltips. So as you hover over the keywords, it tells you what they're for and links to the documentation. It's extremely useful. Yeah. So my app is running, and here is some top class, what is this, Minecraft chat from the YouTube gaming Minecraft category. That's what this app currently does at the moment. So there it is. We'll close that. So our app continues to work, but now the app is no longer running in the root context within the container. So that is good. So we can check that off our list of things to improve the security profile of our containers. So next, what we're going to do is we're going to what's called pin, or sort of explicitly define what version of the base image that we want to use. So why would we do this? You will find that in a lot of examples, people often just say use the like Ubuntu latest tag, as we can see, here. If I just terminate my container and cat the Dockerfile, we're currently using Ubuntu latest, and you'll see things like node latest, Python latest, and so on. And that's great if you want the latest stuff, but when you're putting things into production, you want a bit more reproducibility and reliability. The containers are meant to be ephemeral. They can be created, destroyed, started, stopped, and reproduced with ease and reliability. And using the latest tag is not a single source of truth for your container's bill of materials. So a new version of an update could change the next time you build the container in your CI/CD pipeline, and you won't know that there's a change because it's, in a base image. Mm-hmm. So this importance of pinning is more profound when you're using language ecosystem base images for, Node and Python, Ruby, and so on, or R. I know we've got Eric here, who's, our resident R expert. So you sometimes see examples where they only pin the major version, so node :14, for example. But this carries some of the same risks as using latest, because those minor version bumps can also change dependencies as well, or introduce regressions in behavior, so be explicit about the version. So in the example of our Ubuntu container, we're going to change from Ubuntu latest to Ubuntu 2004. That's the only change we're going to make to the Dockerfile this time. So let's just go and do that quickly.
Yeah, and just a note, Danny's dropping some knowledge in chat, which is awesome. Super cool to see. So she mentions the Docker remote library for VS Code also lets you edit files inside the container, which is super cool. I haven't played around with that too much. But also mentions that you can pin SHA-256 checksum, which you'll actually see in the Slim developer portal if you're in that. When you go to check out an image, we actually do that for reproducibility and sort of the single source of truth for, or the single primary key, I guess, for a container image is actually this SHA value. The
right.
Tags are sort of a roll up of that. So pinning the major minor versions is sort of a really good thing to do if you want to be very, very highly specific. It's a good point that you can actually pin the actual SHA value to it as well.
Yeah, and thanks, Danny, for pointing that out, because this segues very neatly with the next point I'm about to make. So we'll save that. We've just changed from latest to 2004, and I'm not going to build the image just yet. I'm just going to look at my Docker images, and you'll see this. You'll see that Ubuntu latest the ID, or the hash in this case, is the same for latest as it is for 2004. And it's 9 days old, that image. But I have an earlier version of the Ubuntu image, which was Ubuntu latest, and it has a different hash here, and it's 6 weeks old. So there's an important point here. Those 2004 tags for Ubuntu, and this is true for, Alpine and RHEL and BusyBox and all of the other, sort of widely used base images, they may use a tag to denote a version, but as there are security fixes to those major releases, they will release the CVE patches into those container images, rebuild the container images with those fixes, but republish the image under the same tag. But of course the SHA changes. Now this is good because it means you can continue to use the 2004 tag for Ubuntu and know every time you build a container image, you've got the latest security patched version of that LTS container image. So, it's not, as Danny points out, tags don't actually pin you to a point in time. They pin you to a stable release, and only the IDs will actually pin you to a point in time. So just as before, we will rebuild that container image just as we did, but we'll give it pin LTS as the name. And this shouldn't take too long because actually nothing changed, and we can prove that by doing this. Oops, Docker images. So because Ubuntu 2004 and Ubuntu latest are in fact the same thing, although we've changed that Dockerfile, the image ID we get out the other side is the same because nothing has changed other than the tag we gave that image. So no change here. We don't need to retest anything. We can just move on to the next example. So layer caching. So this is a bit more of an in-depth topic. Docker works on the concept of layer caching. It builds images sequentially, laying dependencies on top of one another and only rebuilding them when a layer has changed. So as you saw, if I rebuild this image, it just reassembles everything based on, the cached steps that it's done before. And layer 0 in this case is the base image, and often is. There's one example where that's not true, but we won't get into that today. It's super technical. And it rarely changes significantly, as I was just explaining. You pin yourself to a known major, minor release version. And the commercial vendors, Linux vendors, will publish security fixes to those tags. The application code, however, is likely to change quite a lot during the software development cycle as you iterate on features and refactors and fix bugs. So let's just have a little look at the layers. We'll use Docker history to do that. So if we just list our Docker images, if I could just remember to do the plural, if we do Docker history and then pick the container image ID, we can now see these are the layers that make up that container image, and you read it from bottom up. So this is these first two layers are the base image. So this is the Ubuntu OCI image, this 72.8 megabytes, and this is its entry point that they define, which means if you execute that container, you will drop into the shell. And then this is where my Dockerfile kicks off. So this is where we do the run step, where we update. This is the run step where we install Nano and then Python, where we copy our app in, then where we change the ownership of the files. And then we can see the last two steps don't actually add any size to the container, but we can see that, Nano and Git add 102 megabytes to the container image, and the upgrades add 30 megabytes to the container image. So that's the layers that compose this, and they sort of stack on top of one another to create the whole image. And I've got an example in.
Nice. Yeah, Yannick says that --rm was unrecognized, so I don't know if that's a Docker version issue, or maybe Yannick check and make sure you're doing build. Sorry, was that run or was that build that command was on?
It's run.
The --rm.
It's run here.
So I know I make that mistake all the time of writing build when I mean run and writing run when I mean build, and I just tried to see if I could replicate that while Martin was talking, and I ended up trying to pull the node image, and it's still running. So my computer might lock up, and our podcast makes the comment that he has way too many images, which is the case for me as well.
Right.
So some Docker management needs to happen, but yeah, maybe we'll see if we can help triage that with you. Maybe there's some specifics that we need to look into on that flag, but
yeah.
He says which I'm assuming means he just got it. So
are you up and running? Okay, Yannick has fixed it. Okay, good. That's great. Put the flag at the end. Oh yes, no, you can't do that. I'm glad you're back on the rails again. Excellent. So we ended up creating 4 layers there with 3 run instructions and a copy command. So it's typically a no-no to have lots of layers at build time because that takes longer. But it can be advantageous when you're developing locally to have lots of layers, because then you can iterate faster, because there's lots of steps that don't need to be rebuilt because they can be cached. But we'll try and get the best of both worlds in this simple application. So this is what we're going to do to try and squash some of these layers down into a single layer. So this is the change that we're going to be making to our Dockerfile. We're removing lots of steps. So we're going to copy that. We will edit our Dockerfile, and we will paste this new one at the top here, and you can see the differences. So this is the same. We have what base image we're using, and you'll notice something that I've stopped doing here. So I am doing the update in this new version, but I'm not doing the upgrade, and I'll explain why. Because we know that base image is always going to contain the latest security fixes from Canonical, we don't need to upgrade packages necessarily. The only outstanding updates that might exist for those container images will be bug fixes, and it's unlikely that you need them. So I'm choosing to not add additional stuff to my container image by doing the upgrade. Now, this is debatable as to whether or not you want to do this. You can or you can't. So those are your options. I'm choosing to not do the upgrade because I don't think it's necessary for this application. Then, of course, we're dropping the install of Nano and Git. You know, this container is intended for production. We don't need developer tools inside it. So we've simply erased that entirely. And then before we were just installing Python 3 minimal, but now our line here says we're going to install CA certificates and Python 3 minimal. Now, the reason for that is my app is a web app, and it needs to be able to do TLS, or what was previously called SSL. And therefore you need the CA certificates in order to actually, handle that. Before, Nano and Git were pulling that package in because they're relatively large applications. But because we've stripped things down, we're having to specify that ourselves.
And so this would be similar to like people who use Python a lot, like generally create a virtual environment and then do a requirements.txt file that they export, or people using Node are going to use npm or something like that. That's effectively what we're doing here. We're just installing dependencies, but we want to install only the dependencies that we need, right?
Right. Yeah, trying to keep it as trim as possible. And then we've changed the order a little bit, because now in this new version, we've got the injecting our app into the container as the first step. And that's so that the first line of our run command is actually the changing the ownership of that file. So that means we don't have to have an additional run step just doing those file permission changes. And then here's the last two lines the same, what user we're going to run on and what app are we actually going to run. And then the other thing you can see here is we've used the continuation features so that you can actually keep it readable. So you can continue tacking extra commands on here and have something that reads and scans and is easy to maintain. So that is our revised container. So what we'll do is now build that container with a new tag called squash layers. So we will head back here, paste that in and run it. And because we've changed so much, the only thing that's cached is the base image. That run command is now entirely different. So that is running for the first time, but it is now cached. And it obviously took less time than our first run, or will take less than the first run of our original container, because it doesn't have multiple run steps pulling in unnecessary stuff. So if we look at Docker images now, here's our new container image, and we can see that's considerably smaller, which is not to be unexpected, because obviously it doesn't have Nano and Git and all of their dependencies smushed inside it. But if we run that app here, we can run it like so. Our application should still work.
Yeah. Nice. Nice. BigPod's making the point that there's actually a flag in the Docker run command called squash that will squash the layers for you when you're when the image, which I think that's cool and interesting. I think I don't know, BigPod, have you looked at that from I guess there's some different use cases, like certainly if you're going to production, you want that to happen, and that probably does it for you automatically. I'm curious if there's other use cases where you would kind of want to know which layers go into the file, and just kind of have an optimized Docker file in general. I don't know. It's interesting. I haven't played around with the squash command in Docker too much. I'm just curious people's.
And now if we use Docker history again, we can now use the image for our squash layers build, and we can see it has far fewer layers. And really, this is the big one where everything happens, where that one command all runs together and 70 megabytes of stuff is added to the container image. Yeah.
BigPod says that he mostly uses it to squash a couple of containers, which I think it makes sense. When you have a container that works, and it's the one you want, and you're not going to use it again, right? Squash the layers, make it smaller. That's sort of the same concept as a multi-stage build, where you're essentially creating two images, and then the last image is one layer on top of sort of the base image. So it's a good concept, and I think it's definitely worth looking at. I think we should dive into the sort of squashing of layers a little bit more later on. So that's great.
Definitely.
Nice.
So there we go. Now this example is about removing, let's call it cruft, from your image. You don't want to be Yannick, I'm so glad that you're getting value out of these. Welcome to the Docker Expert
to your
Club.
LinkedIn profile. I think you'll have recruiters knocking down your door in no time. So
indeed. So what we want to do now is we want to remove cruft from the container image. We want to remove anything that's unnecessary inside it, so that we're not moving data around and bits around that we simply do not need. Now, package managers, and this is true for Linux distro package managers like apt and yum, but also for tools like npm and gem and pip and all the language ecosystem. Package managers have the ability to clean up their own caches. Now, because we're not installing anything with pip, we are going to use apt's mechanisms to clean up the caches. So we're going to be adding these 3 lines to our Dockerfile. And what that will do...
Danny previewed this one for us as well. She was ahead of the curve in the class. So so this was something you could do in the last step. So I was going to comment that it was coming. So
excellent. All right, Danny, you can go to the top of the class, gold star. So if we edit our Dockerfile and add those lines to the end here, we just need to chain the command and continue and then paste that in there. So we're going to attempt to remove any packages that are installed on the system that are orphaned, that don't need to be installed anymore. This will actually do nothing for our current container image. We will also auto clean the apt cache. So if you've got a large application with lots of dependencies, you will end up with things sitting around in the apt cache that now your container is hoofing around the place. You don't want that. This will clean up most of it. And in fact, because these images are not going to be operated by people, once they're created, this is their state that they're going to be in for operation. We can be quite brute force about it. So actually, we're just going to remove entirely everything to do with apt and dpkg caches and their log files from the image entirely. Now, this is a slightly contrived example because this isn't going to make any, due to rounding errors, this isn't going to make any significant difference to our container image size, but it illustrates a point about something that you should do. It's trivial to do these sorts of things, and you should do them, and you should implement the equivalent of these cache cleanups for whatever languages and frameworks you're using in your application. For the examples of Python, you may want to actually compile the bytecode for the Python and leave the bytecode in the container, because that then means that the container will execute more quickly. Or if you want to keep the size of the container down, you could go and strip all the PyC and PyO files out, but it's entirely up to you which approach you take.
Okay. We had a question about apt versus apt-get. Again, Danny's on it, but it's funny because I asked you that same question as we were preparing this tutorial. I think the difference between using apt and apt-get in these contexts.
Yeah, generally speaking, apt today is like a top-level wrapper that sits around all of those apt commands, whereas apt-get was kind of a subset of commands, and then you had to use apt cache for something else, and apt kind of just wraps everything up neatly now. So we'll build our container image just because, and we're using the tag cache clean. And again, because our run command, because it's a continuation, this looks like a new, a new run step. So that whole step had to run in completion. Now it's cached. But as you can see, it doesn't actually make any tangible difference. I did go poking around, and you'll find out how I went poking around in detail on this tomorrow in our office hours workshop in our Discord channel. And if there's anyone here who's wondering where our Discord channel is, I'm going to paste this again. Go and join that. We'll be doing a live workshop there tomorrow. I'll be showing, Peter and I'll be showing you how to use the Slim developer platform to really sort of introspect and show the differences between revisions of Docker images.
Mm-hmm. Ollie says, "Hey Ollie, it's good to see you." He says it's amazing how much you can delete from a Debian system and still have it work. I feel like that sounds like a challenge. Maybe we can play around with that in office hours too. Just see how much exactly you can delete from your Debian Docker image and still have it work.
That would be a fun one, because there's a command in Docker Slim. There's one command in Docker Slim to say absolutely preserve these files regardless of anything, and there's another one to say I really know what I'm doing, trash these things. So I'm quite familiar with how Ubuntu is put together. So, we could have some fun and see just how much could we axe out of the system. But then, of course, Docker, and also, is there anything that Docker Slim isn't axing out of the system that we could manually influence? I probably think not, but we could experiment with that. It would be a fun experiment. So I'm not going to run this image because I have a high degree of confidence that's going to continue to work, because technically speaking, nothing changed that affects the app. But that's how you would run that tag. So we're just going to talk a little bit about entry points instead of CMD. Now, as it happens, we inherited some good practice from our first workshop, because we've been using entry point all the way through these examples. So if we look here, our entry point is this, and it says use the Python 3 interpreter to run this Python file. Now, there are some subtle differences between CMD and entry point, and there are reasons why you might want to use one over the other. So generally speaking, the best rule of thumb is this: if you are putting a container into production, use entry point, and only use CMD in local development environments, if you use it at all. And here's why. Entry points are fixed. That is the thing that gets executed when the container starts, and you can't change that initial entry point. You can augment it by running the container and adding commands on the end, like additional parameters to, in fact, we do precisely that, because if we look at our docker run command here, right, here we go. This says run our container, and this bit of the command here is actually parameters that we're passing to the app inside the container. We're telling it what IP address to bind its service to, and then this random jumble of letters is the channel ID for the Minecraft gaming community on YouTube. So but the one thing we can't change is we can't change which application is being launched. It is our Python file. Whereas if you use CMD instead of entry point, you can completely replace the command that you execute when you start the container. You can completely override it. So that can be useful when you're developing locally, because maybe you want to run some sort of debug or test case or something like that inside the container as opposed to the main app. Or maybe you just want to shell into the container. So, those are some of the advantages.
Yeah, that's the use case I see most often, is finding CMD files in kind of containers that are meant to be interactive, and you shell into it, you do something, and BigPod and our podcast make the comment they always use entry point, which is the same case for me. Danny makes the comment that the best containers use both, which now I'm like, oh, okay, definitely on a different level. So I'd be curious to see some examples of using both and why, and explore those use cases for sure. That's cool. So.
Well, you could for multi-stage builds as well.
Sure.
Yeah.
Sure.
Right then, and I think we could get into maybe if any of these keywords are of particular interest, maybe we can just do a deep dive on some of them in the future, like entry point and CMD, and really explore their use cases. So our last little bit of sort of best practice is using WORKDIR. So the WORKDIR instruction sets the working directory for any subsequent add, copy, run, CMD, or entry point instructions that follow it in the Dockerfile. So for clarity and reliability, you should always use absolute paths for your WORKDIR, and you should always use WORKDIR instead of using instructions like cd somewhere, do things in that directory. You absolutely can do those things, but you'll soon find if you've got a complex app that you're putting inside your container, it's going to get hard to read, hard to maintain, and when you get problems, it's going to be hard to figure out where they are. So we're going to add a WORKDIR to our container, and it's just this single line here. We're going to put our application inside my app. None of these other lines need to change, because by setting this, the copy and run and entry point commands that follow are effectively in this directory from that point forwards. So that's the only command the only instruction we need to add to our Dockerfile. So we'll do that now.
And that's just basically the equivalent of on your local system setting the current working directory or your present working directory, but you're just doing it in the container for sort of knowing where the files are going to live, right? That's the whole purpose of this. Yeah.
And we'll rebuild this with a new tag called WORKDIR. Now this isn't going to change the size of anything, but it does introduce a new step, and the run command that follows now needs to be rebuilt and cached because it's effectively different, because its point of origin is in a different spot. And if we look at the Docker images, we can now see it. And of course, there's no change in size because all we've done is added a directory in effect. And, we can pick up our how to run our app here and run it.
Cool. And
there it is. And it should just work the same. So let's just prove that this is not smoke and mirrors. 127 and goodness. Oh, there we go. It just took YouTube was slow. It's not us. There we go.
YouTube, always blame YouTube.
So there we go. So now what we can look at is we've refactored our Dockerfile from sort of our beginner-friendly example that we built a couple of weeks ago to this that's now more suitable for putting in production. It's smaller, it's better secured, it's got pinned versions and all sorts of things. So let's take a look at what we changed here. And if we just do a git diff here, we can see the lines removed and the lines added whilst we've been making these changes. And really the more interesting things is looking at what didn't change. So what didn't change is this. Now, although this is only a single line, you can read this as putting my application in the container. Maybe that is a series of, or maybe that's a run step where you have, line continuation to npm install some stuff to, stand up a database schema or whatever it might be that your application needs. And you can put all of that app specific stuff in its own block. But then all of this other stuff for providing runtime can be, broadly speaking, quite static. So your local development builds don't have to reprocess that each time. But this only works for small apps, and multi-stage builds are the solution for, solving this. I want fast local development and production images all originating from a single Dockerfile, and that's something we'll cover in a future workshop.
Okay. Very cool. Well, that's really interesting. Touched on a lot of concepts about kind of making better Dockerfile, and so I think it's a nice extension from sort of the general tutorials of here's just from node latest, copy my app, run and go. And so this is sort of like the next step to improving your Dockerfile and understanding at a deeper layer what Dockerfile is doing. So thank you, Martin. That was really cool. That was really awesome to see. So it looks like people in chat did okay. It looks like Monica, Community Tea Time, was still with us. Yannick, French guy, he looks like he got it in the end, but maybe had an extra line in his Dockerfile, or maybe it was just a case of the diff being different. But so far, it looks like everybody's doing well.
Excellent.
100%.
Yes. Okay. So yeah, we've got success being reported. That's good. And yeah, so I think we can get into multi-stage builds as a future workshop for sure. I think that's one that you and I are both interested in learning more about anyway, Pieter.
Yeah, absolutely. And it's kind of interesting to see how that interacts with Docker Slim, what Docker Slim is doing, right, which is kind of a different approach, does a lot of this stuff automatically. Kyle, the CTO of Slim, has offered to do a tutorial on build packs, which is kind of a cool technology that will actually just like take your app, no Dockerfile needed, and sort of do this automatically. So there's a lot of cool stuff out there that sort of interacts with different ways of building containers. So there's a lot to explore now that we have sort of the fundamentals down. So
yeah,
hope people are interested in that. Yeah.
So Ali asks an interesting question, which is, imagine for a moment that I don't want to use a base image, that I want to in an Ubuntu world, I want to bootstrap my own OS. I want to do it all from the absolute rudiments. Can you start from scratch? And you can. And what you would do is you would change this and you would say scratch, and you start with a container image that is 0 bytes. And from that point, you would run a series of commands here, deb bootstrap. I can't remember all of the options, but you would then run things like this to actually flesh out the runtime for your own container. So yes, you can absolutely start from nothing.
Yeah. And that comes into multi-stage builds because you use that scratch image to build from those. So I think that's interesting. Yep. It hurts my brain a little bit to think about, like, I have so many questions about that, but our podcast does the same thing. I haven't been brave enough to try that yet. Bends my mind a little bit to this. So what's the OS in the scratch image? That's like, I don't know if that's like
so we can see this for real in the Ubuntu image. Okay, so if we go and look at the 2004 image, here is the Dockerfile for that Ubuntu base image that we were just using from scratch, and then it adds that tarball. That tarball is basically it's what Canonical call an optimized OCI image. So it is built with the tools to actually bootstrap just enough operating system, put inside a tarball, and basically it says, well, add that tarball to the root file system, which is 0 bytes, and there it is. There's your base image. So while you could do deb bootstrap, Ali, if you do the deb bootstrap in a separate bit of your CI/CD pipeline and create a tarball, then you can just have a very small Docker file like this to actually turn that tarball into your base Docker image.
Okay, very cool. Danny asks, whatever happened to Ubuntu? Oh, I can't pronounce that. JeOS?
Juice. Yeah, it was called Juice, and it was it stood for just enough operating system.
Okay. Nice.
And the reason it went away is because these container images are produced now. So all of the major cloud platform providers have optimized images for their platforms, and these container images exist. I mean, if we just go back here again, and just remind us, I've done it again. And just remind ourselves, if we just go to the terminal and we do Docker images, we can see that the Ubuntu base image is 72.8 megabytes. And I know for a fact that those Juice images were bigger than that. So, it was like a stepping stone to get to this point where there are just small, Ubuntu container images.
Nice. Well, awesome. Well, that looks really great. And it says you're a new streamer. We're just trying to give console.dev a few extra plugs, So come to our Discord, but also check out console.dev. Pretty cool content coming out from them.
Yes.
But have we earned our cookies? I think we've earned our cookies, or Slim socks, or whatever it is, Slim stickers. Somebody made a comment in the chat earlier that cookies actually ship pretty well, they've heard. So we'll look into that. But come into our Discord and ping Martin, and we can get you guys some socks and stickers.
I can see Yannick has taken me on my word there. He's sent me a message with cookies and socks. Bit greedy there,
cookies
Yannick,
and
but
socks.
We'll sort you out. So there's a link to our Discord channel. Join there. We'll be doing an office hours continuation of this tomorrow. So like how to do introspection and explore your containers and diff your containers. And if you join our Discord and you message me, I'm Wimpy, and you send me emotes of socks or what was it Gillian said we got? Socks or something else? Socks and
stickers and t-shirts. I think those are the things that are got plenty of. So
we've got Cody emotes in there, so yeah, by all send me a Cody emote. Let me just find one of those. There we go, like that. Send me one of those, or cookies or socks or whatever. And if you want those things and you're happy doing it, PM me a shipping address and we'll get those things sent out to you.
Yeah.
Right.
Wonderful.
I think that's it. So if you're thinking about next steps and you want to join tomorrow's office hours, then you may want to head over to Slim.AI and get early access. So get signed up on the Slim developer platform, because what we show you tomorrow, you'll then be able to log in and start using.
Mm-hmm. Yep, that's a great step. And yeah, ping us on Discord and we'll be in there tomorrow. And then looking forward to Containers 101, the volumes version next week. So that's going to be a personal challenge for me. I haven't played around with it a ton. I love working with databases like Postgres and MongoDB. I have an app I've been working on that uses both of those right now, so I've been trying to containerize that. So I'm excited to explore that and share that with you all, and hopefully get some feedback where I steer it wrong, but that'll be a good one. So
yeah.
Until then.
Yep. Until then, thank you all for coming. Hopefully we'll see you tomorrow, and if not, we'll see you next week for Containers 101 volumes.
Mm-hmm.
Thanks, Peter.
Cool.
Thanks, everyone, for coming. Apply for your socks in Discord, and we'll speak to you soon.
All right. Thanks
Bye-bye.
a lot. See ya. Bye.